My name is Jaga, although almost everyone at the facility called me Dr. Jaga. I spent nearly 11 years working in infectious disease research, and in that time I had seen things that would probably make most people avoid hospitals for the rest of their lives. I had worked on antibiotic-resistant bacteria collected from war zones overseas. I had worked with blood samples carrying diseases that no longer existed anywhere outside laboratory freezers. I'd even spent 6 months helping develop treatments for a hemorrhagic fever outbreak in South America that never made international news because it was contained before it crossed any borders. None of those experiences prepared me for what arrived at our facility on a Tuesday morning in early October. I worked at a private medical research company outside Baltimore, Maryland. Calling it a laboratory would be underselling it. The place looked more like an airport mixed with a hospital and a military base. We had our own security division, our own emergency response teams, and enough backup generators to power a small city. Most people have never heard of companies like ours because we worked behind contracts and confidentiality agreements. Pharmaceutical companies, governments, and private organizations sent us the cases they either could not solve or could not afford to fail. Every day, hundreds of samples arrived at our loading bay. Blood, bone marrow, tumor biopsies, spinal fluid, sometimes entire organs preserved in transport containers. Most of them followed the same path. The sample arrived, we ran tests, identified the problem, wrote reports, and moved on to the next case. That Tuesday started exactly the same way. I was halfway through reviewing overnight reports when my office phone rang. My assistant, Rebecca, asked if I could come downstairs immediately because security was requesting my authorization in receiving Bay 3. That was unusual. Normal deliveries did not require authorization from department heads. I took the elevator down expecting paperwork problems or damaged containers during transport. Instead, I walked into 4 armed security officers standing beside a silver transport case about the size of a microwave. The case had no company logos, no hospital markings, no shipping information, just a barcode and a red label that read Level 4 Priority. One of the officers handed me a tablet and asked for my credentials. I signed the release form and noticed the sender information had been hidden behind government clearance restrictions. That got my attention. Government samples were rare. Anonymous government samples were almost unheard of. Rebecca must have noticed my expression because she leaned closer and quietly asked if I knew what we were looking at. I told her I had no idea. That answer turned out to be the truth. Inside the case were 3 blood samples stored in reinforced containers designed for highly infectious material. 3 tubes, each containing about 10 milliliters of blood. Nothing else. There was no tissue samples, no patient history, and no medical notes. Just 3 tubes and a confidentiality agreement waiting for my signature. The agreement itself was stranger than the samples. Normally, these documents covered patient identity and proprietary information. This one specifically prohibited discussing the source of the samples with anyone outside the assigned research team, including local authorities, federal agencies, and other departments inside our own company. Rebecca read the document over my shoulder and asked who exactly had enough power to make those demands. I looked at the authorization code at the bottom of the page and recognized the family name immediately. A billionaire, one of the richest men in the country. His daughter was the patient. Apparently, every major hospital she visited had failed to explain what was happening to her. By the time the samples reached us, she was already in intensive care. Our job was simple: find out what was killing her. I remember feeling almost relieved after hearing that. Unknown illnesses were exactly what our department existed for. Put enough experienced researchers in the same room and eventually somebody finds the answer. That was how science worked. At least that was what I believed at the time. The first thing we did was run the blood through a centrifuge. For anyone unfamiliar with laboratories, the machine spins samples at extremely high speeds, so different components separate into layers. Healthy blood behaves predictably. Every technician in the room already knew what the results would look like before the machine even started. 20 minutes later, the centrifuge stopped. One of the interns removed the first tube and held it under the overhead lights. Nobody said anything. The sample looked exactly the same. The layers had not separated. The plasma had not risen to the top. The red cells had not settled at the bottom. It looked as if the machine had never been turned on. The intern assumed he had loaded the settings incorrectly and prepared another sample. The second test produced the same result. So did the third. Rebecca picked up one of the tubes and rotated it slowly in front of the light. That was when she noticed the strands. At first, I thought they were cracks in the glass. Thin black lines drifted through the blood as if someone had dropped pieces of thread into the sample. When the tube moved, the blood moved with it. The black strands did not. They remained suspended in place for almost 2 seconds before slowly changing position. One of the researchers suggested clotting. Another suggested contamination during transport. Both explanations disappeared when we opened the second tube and found the same thing. The third tube looked identical. I took one of the samples myself and walked it to microscopy room 2. The entire team followed behind me. I prepared the slide personally because, by that point, I wanted to eliminate every possible mistake. The sample went under the microscope. I adjusted the focus. At first, everything looked normal. Red blood cells, white blood cells, platelets. Then I increased magnification. One of the black strands came into view. It was attached to the surface of a blood cell. Actually, attached was not the right word. Wrapped around would be more accurate. The structure curved around the cell several times before disappearing beneath it. I increased magnification again. Rebecca stood beside me, waiting for an explanation. Instead, I moved away from the microscope and told her to look for herself. She adjusted the lens for maybe 5 seconds before asking me if the image on the screen was live footage or recorded footage. I told her it was live. She looked back into the microscope, then back at me, then back at the microscope again. The blood cell at the center of the screen had changed position. It didn't drift, nor did it float. It just changed position, because the black strand wrapped around it had tightened, and the cell was smaller than it had been a few seconds earlier. The room suddenly felt much smaller than it had 5 minutes before, because every person standing there had arrived at exactly the same conclusion, whatever we were looking at. It was still active. Nobody in that room said the word virus. It was not because we had not considered it. Every person standing around that microscope had probably reached the same conclusion already. The problem was that saying it out loud would mean accepting that we were looking at something we could not explain. Rebecca eventually broke the silence by asking whether I wanted the recording archived. I told her to save everything. Every recording, every image, every scan, and every test result. If this turned out to be contamination or faulty equipment, we could always delete the files later. If it was something else, I wanted evidence that we had seen it with our own eyes. The first thing we investigated was whether movement in the slide itself was creating the illusion that the strands were moving. Microscopes are extremely sensitive instruments. Vibrations from nearby equipment, changes in temperature, or even someone resting their hand on the table can create movement that appears dramatic once magnified thousands of times. We repeated the test using equipment isolated from vibration. The same thing happened. We prepared another slide using blood from a different tube. The result was identical. By lunchtime, we had tested 12 separate samples, and every single one behaved the same way. The black strands attached themselves to nearby blood cells and remained connected to them while the cells slowly changed shape. After a while, the cells disappeared completely. What disturbed us was not that the cells were dying. Cells die all the time. Blood samples contain damaged cells, dead cells, and broken cells every single day. What we could not explain was the complete absence of anything left behind after the process finished. When a cell dies, something remains. Fragments remain. Proteins remain. Waste products remain. There should have been some evidence showing us where the material from those cells had gone. Instead, there was nothing. One of the younger researchers eventually asked the question everyone else was avoiding. He wanted to know where the missing material was going. Nobody answered him because nobody had an answer. Later that afternoon, we moved to electron microscopy. Normal microscopes can only reveal so much detail. Electron microscopes allow us to see structures thousands of times smaller than a human hair. If we were dealing with a virus, this would be the point where we finally saw what it actually looked like. The first images finished processing shortly after 6 in the evening. Rebecca was standing beside me when the scans appeared on the monitor. Most viruses have recognizable shapes once you work in the field long enough. Some are spherical. Some resemble tiny capsules. Others almost look mechanical under magnification. This looked like none of them. The structures were hollow and branch-like. Thin extensions spread outward from a central body and wrapped themselves around surrounding cells in ways that reminded me more of plant roots than microorganisms. One of the imaging specialists quietly commented that it looked less like a virus and more like a tree growing inside the bloodstream. Normally, that kind of joke would have earned a few laughs. Nobody laughed. The comparison felt uncomfortably accurate. The images became even harder to explain once we compared scans taken several hours apart. The structures were changing. Not reproducing. Changing. Features visible in the morning scans had disappeared entirely by evening, and new structures had formed in their place. It felt less like studying different generations of the same organism, and more like looking at photographs of completely different organisms occupying the same sample. By midnight, almost half the department was still inside the building. Researchers are not known for staying late unless deadlines are involved, yet nobody wanted to leave that night. Every person in the room seemed to be waiting for someone else to explain what we were seeing around 1 a.m. Rebecca walked into my office carrying a tablet and asked me to come downstairs. She led me to one of the observation rooms where a blood sample had been sitting under continuous recording for several hours. The footage was being played back at high speed. At first, I thought she was showing me ordinary cell movement. Then she rewound the video. A white blood cell drifted into the middle of the frame. The black strands nearby slowly changed direction and began moving toward it. The movement was subtle enough that I probably would not have noticed it without the accelerated footage. But once you saw it happen, there was no other explanation for what you were looking at. Over the next several minutes, the distance between the strands and the white blood cell became smaller until contact was made. The cell stopped moving shortly afterward. The strands wrapped themselves around its surface and remained attached. 20 minutes later, the cell was gone. Rebecca looked at me and asked whether viruses could hunt. I told her no, at least none that I knew of. The following morning, we began genetic sequencing. This was supposed to be the straightforward part of the investigation. Every virus carries genetic information that can be compared against international databases. Even newly discovered viruses usually resemble older ones closely enough for researchers to identify their relatives and predict their behavior. The first sequencing attempt failed. The machine reported corrupted data. We assumed the sample had degraded during transport and tried again. The second test produced a completely different sequence. The third produced another one. By lunchtime, we had obtained several different results from the same blood sample. One of the technicians blamed the sequencing machine and requested another system. The replacement machine produced different results again. Rebecca stood beside the printer reading through the reports and asked me which result we were supposed to trust. After reading through the pages myself, I told her that we might have to trust all of them. She thought I was joking. I wasn't. Viruses mutate all the time, but those changes usually happen over weeks, months, or even years as they spread through populations. They do not rewrite parts of themselves over the course of a few hours while sitting inside a sealed laboratory refrigerator. That afternoon, we reviewed the original transport records. The blood had been collected 4 days before arriving at our facility. 4 days without a living host. 4 days without fresh tissue. 4 days without access to nutrients. Despite all of that, whatever existed inside those samples was still changing. Around 4 in the afternoon, I received my first update on the patient. She was 23 years old and had no history of drug use, no major illnesses, and no underlying medical conditions that could explain what was happening to her body. According to her doctors, her liver had started failing 2 days earlier, and signs of kidney failure had appeared that morning. The physician on the other end of the call asked whether we had identified the cause yet. I told him we were still investigating. That answer was technically true. The truth was that after more than 24 hours of testing, our department still could not answer the most basic question in infectious disease research. We still did not know whether the thing inside that blood was even alive. Later that evening, I returned to the microscopy room to review the newest recordings. Most of the team had gone home for a few hours of sleep, leaving the room unusually quiet. The black strands were still visible. The blood cells were still disappearing. Then I noticed something unusual. There were fewer strands visible in the sample than there had been earlier in the day. At first, I assumed the numbers were dropping. After zooming in, I realized that was not what had happened. Several of the smaller strands had merged together and formed larger structures. I checked the timestamps repeatedly because I was convinced I had made a mistake somewhere. The entire process had happened in less than 6 hours. I remained in that room for a long time, staring at the monitor because my thoughts had changed completely. Up until that point, I had been asking myself what this thing was. For the first time since the samples arrived, I found myself asking a different question. What exactly was it becoming? By the beginning of the 3rd day, everyone in our department had accepted the same uncomfortable reality. Whatever existed inside those blood samples was not going to identify itself for us. We were going to have to learn about it the hard way. That meant moving to animal testing. People outside medical research often imagine laboratories as places where scientists mix colorful liquids in glass tubes until they discover a cure for something. The reality is far less glamorous and a lot more uncomfortable. Before any treatment can be tested on people, researchers have to understand how a disease behaves inside a living body. There is no shortcut around that process. Our first subjects were mice. The procedure itself was routine. Blood samples were diluted, measurements were taken, and the exposure levels were carefully controlled. We had performed similar experiments hundreds of times throughout our careers. The first mouse showed no signs of illness during the first hour. Neither did the second. By the second hour, one of the technicians noticed changes in body temperature. By the third hour, the animals were becoming less active. That alone was not unusual. Sick animals often become quiet and conserve energy. What confused us was how quickly everything was happening. Most infections follow a pattern. Symptoms appear. The body responds. The immune system fights back. There is a progression that researchers can observe and measure. This infection seemed to skip entire stages. Around the fourth hour, one of the mice stopped eating. Another stopped drinking. The third remained standing beside the water dispenser for almost 15 minutes without moving away from it. One of the technicians initially thought the animal had died standing up, until it eventually turned and walked back toward the corner of the enclosure. Its movements looked normal. Its breathing looked normal. Its heart rate was normal. According to every monitor attached to the enclosure, the animal was alive and stable. 6 minutes later, it collapsed. The monitors recorded complete system failure almost immediately afterward. There was no struggle, no seizure, no visible distress. One moment the animal was alive, and the next moment every reading on the screen dropped at the same time. I reviewed the data 3 separate times because I was convinced we had experienced equipment failure. The results were identical every time. The same thing happened to the second mouse 23 minutes later. The third survived until morning. By the time we arrived at work the following day, it was dead too. Rebecca spent most of that morning comparing the data from the mice with the medical reports from the billionaire's daughter. The similarities were impossible to ignore. The body temperature changes matched. The organ damage matched. Even the timing of the progression looked similar. The difference was speed. Whatever had taken weeks to destroy the patient was destroying smaller animals in a matter of hours. By lunchtime, we moved to rabbits. The results were worse. One rabbit survived for almost 12 hours before the infection reached its nervous system. The footage from that experiment still exists somewhere in the company archives, although I doubt anyone has watched it in years. The rabbit was walking normally around the enclosure when it suddenly stopped beside the feeding tray. For the next several minutes, it remained there without eating. One of the veterinary specialists entered the room expecting dehydration or exhaustion. The rabbit turned toward him immediately, not toward the sound of the door opening. Toward him. The specialist later told us he had the strange feeling that the animal had been waiting for someone to enter the room. A few minutes later, it collapsed. When the autopsy began, we expected to find widespread organ failure. Instead, we discovered something that made even our senior pathologist stop speaking for a while. The damage was far more extensive than the scans had suggested. Large sections of tissue had simply disappeared. Not damaged, not infected. Gone. One of the lungs weighed almost 30% less than it should have. Part of the liver was missing entirely. The pathologist checked the measurements repeatedly because he believed someone had made a mistake during the examination. Nobody had. Rebecca eventually asked where the missing tissue had gone. That question was becoming disturbingly common inside our department. The answer remained the same. Nobody knew. By the end of the week, we moved to primates. Nobody wanted to say it out loud, but if the infection behaved similarly in monkeys, then we would have a much clearer understanding of what was happening to the patient. The first monkey remained healthy for nearly 8 hours. The second survived for 12. The third lasted almost an entire day. Their symptoms followed the same pattern every time. Loss of appetite, fatigue, organ damage, system failure. The progression was becoming predictable. That should have made us feel better. Instead, it made us feel worse. Predictability meant we were beginning to understand the timeline. Understanding the timeline meant we could start estimating survival rates. The numbers were not encouraging. Late one night, I stayed behind to review recordings from the primate observation rooms. Most of the department had gone home by then. Rebecca had left an hour earlier after promising to return before sunrise. I was sitting alone in front of a monitor, showing one of the infected monkeys, when something caught my attention. The animal had spent the last hour sitting near the observation window. That by itself was not unusual. Primates are curious animals and often watch researchers moving around outside the enclosure. What caught my attention was the timing. Every time someone walked past the room, the monkey turned its head and followed them with its eyes. That was normal. What happened next wasn't. A maintenance worker walked down the hallway, pushing a supply cart toward the elevators. The monkey followed him with its eyes until he disappeared from view. Then it turned and looked directly at the camera mounted above the enclosure. It kept looking at the camera for almost 3 minutes. Eventually, I checked the timestamps because I assumed I was imagining things. I wasn't. The animal was staring directly into the lens. A few moments later, the heart monitor beside the enclosure began showing irregular activity. 30 seconds after that, every alarm in the room activated simultaneously. The monkey died less than a minute later. I remained in the observation room for a long time after the alarm stopped. Not because I was frightened. At least that is what I told myself at the time. The truth was that I was trying to understand something that made absolutely no sense. The scans showed extensive damage throughout the body. The organs were failing. The infection was spreading exactly as expected. We drew a fresh blood sample from the monkey less than 5 minutes after it died. Under the microscope, the blood looked exactly like the samples we had received 3 days earlier. The black strands were still moving. The animal was dead, but whatever lived inside its blood clearly wasn't. That was the moment we stopped treating it like an aggressive virus and started asking whether we were dealing with something medicine had never encountered before. The morning after the monkey died, nobody in our department was talking about treatments anymore. For the first 3 days, every discussion had been centered around one question. How do we stop this? By the 4th day, the question had changed. What exactly are we trying to stop? There is a big difference between those two questions, and every researcher in that building understood it. You cannot develop a cure until you understand what you are fighting. That morning, I called everyone assigned to the project into the main conference room. There were a little over 20 of us by then. Virologists, pathologists, microbiologists, geneticists, veterinarians, and laboratory technicians were all sitting around the same table with coffee cups that had probably been refilled 3 or 4 times already. I started the meeting by asking everyone to forget the word virus for a moment. A few people looked confused. I explained that we had been calling it a virus simply because we had never seen anything else that came close. The truth was that none of our tests had actually confirmed it belonged to any known viral family. Until we had proof, we needed to stop making assumptions. Rebecca nodded in agreement before placing several printed microscope images on the table. The pictures had been taken over the previous 3 days. At first glance, they looked identical. Once you looked closer, the differences became obvious. The structures inside the blood were changing shape faster than any microorganism any of us had ever studied. One of the geneticists pointed at 2 photographs taken only 8 hours apart and asked how the same structure could look completely different in such a short time. Nobody answered him. We were all hoping someone else had an explanation. The meeting ended without one. The rest of the morning was spent examining tissue collected from the animals that had died during testing. Normally, an autopsy confirms what researchers already suspect. This one only created more questions. The first surprise came from the monkey's liver. The scans taken while it was alive showed widespread damage, but the organs sitting on the examination table looked worse than the images suggested. Entire sections of tissue were simply missing. There were no cuts, no tears, no signs that anything had physically removed them. It looked as though parts of the organ had slowly disappeared from the inside until empty spaces were left behind. Our chief pathologist measured the remaining tissue several times before asking for the rabbit's liver. It showed the same pattern. Then we checked the mice. Exactly the same. The damage was different in size, but identical in appearance. Rebecca stood beside me while we compared photographs from all 3 animals. She quietly asked whether the organism was feeding on living tissue. I told her I did not know. The truth was that I had started wondering the same thing the night before. By early afternoon, we decided to compare infected blood with healthy blood under identical conditions. We placed the 2 samples under separate microscopes and connected both cameras to the same monitor. Healthy blood behaved exactly the way blood should. The cells drifted naturally through the fluid. Nothing unusual happened. The infected sample was different. The black strands were still present. Over the next hour, they slowly attached themselves to nearby blood cells just as they had in every previous experiment. One of the interns suggested introducing healthy blood into the infected sample to see what would happen. It was a reasonable idea. We all watched the monitor as a tiny amount of healthy blood was added to the slide. At first, nothing changed. Then one of the healthy blood cells drifted close to a black strand. Within seconds, the strand wrapped itself around the cell. Rebecca started timing the process with her phone. The cell slowly changed shape before disappearing completely. She stopped the timer and looked at me. It had taken less than 3 minutes. That was the fastest we had seen so far. The organism was becoming more aggressive. Late that afternoon, my office phone rang again. It was the physician treating the billionaire's daughter. I recognized his voice immediately. He sounded exhausted. He asked whether we had identified the disease yet, because her condition had become critical overnight. I asked him what had changed. He told me her lungs were beginning to fail. That caught my attention immediately, because our earlier reports showed the infection attacking the liver and kidneys first. I asked whether they had confirmed the lung damage. He said they had repeated the scans twice. There was no mistake. Whatever was happening inside her body was spreading faster than before. Before ending the call, he asked me one question that I still remember clearly. He asked whether he should prepare the family for the worst. I looked through the latest reports scattered across my desk. None of them contained good news. I told him that I thought it would be wise. After hanging up, I sat there for several minutes without touching the paperwork in front of me. Scientists are trained to separate emotions from research. Most of the time, we managed to do that. That afternoon was different. For the first time since those blood samples arrived, I stopped thinking about the patient as a case number. She was a young woman whose family was waiting for answers that I still could not give them. Around 6 that evening, Rebecca walked into my office, carrying another stack of laboratory reports. She placed them on my desk and told me she thought we had finally found something useful. The sequencing team had isolated a section of genetic material that appeared in every sample we had tested. It did not matter whether the blood came from the original patient, the mice, the rabbits, or the monkey. Every sample contained that exact sequence. It was the first thing that had remained unchanged since the investigation began. That might not sound important, but for us it was the first solid piece of ground we had found after days of sinking deeper into confusion. For the first time, we had something we could study without it changing every few hours. I remember looking at Rebecca and telling her that we might finally be making progress. She smiled for the first time in days. Neither of us knew that while we were celebrating our first breakthrough, the outbreak had already reached someone outside the laboratory. We just hadn't heard about it yet. The following morning started better than any of us expected. For the first time since the samples had arrived, people were actually smiling. The sequencing team had spent the entire night studying the section of genetic material that remained unchanged across every sample. We finally had something stable to work with. It was nowhere close to a cure, but at least we were no longer chasing a target that changed every few hours. I walked into the laboratory just before 7 in the morning and found Rebecca asleep at her desk with a stack of printed reports under her arm. Someone had draped a lab coat over her shoulders like a blanket. Empty coffee cups covered half the table, and the sequencing machine beside her was still running. I tapped lightly on the desk. She opened one eye, looked at me, and immediately asked if the overnight cultures had finished growing. I laughed and told her she had been asleep for less than an hour. She looked around the room as if she had forgotten where she was before rubbing her face and standing up. "I'll sleep when this is over," she said. At the time, I believed her. Looking back now, none of us realized how long over was going to take. Around 9 that morning, we held another meeting with the physicians treating the billionaire's daughter. They connected through a secure video call from the intensive care unit. We could not see the patient, but we could hear the machines around her. The lead physician told us they had exhausted every approved treatment they could legally give her. Nothing was slowing the disease. I asked him how quickly her condition had changed overnight. He looked down at his notes before answering. Yesterday she could still respond when her parents spoke to her. This morning she isn't responding at all. Nobody in our conference room said anything. He continued explaining that her liver and kidneys had almost completely stopped functioning, and her lungs were now deteriorating much faster than expected. Before ending the call, he asked whether our team had identified anything that could help them. I told him about the stable genetic sequence we had found. He thanked us, although both of us knew it would not help his patient in time. As soon as the meeting ended, I assigned half of our department to focus entirely on that sequence. Every other project inside our division was paused. Researchers from different departments began joining us, bringing experience in genetics, immunology, and molecular biology. The laboratory became busier than I had ever seen it. People who had never worked together before were now standing shoulder to shoulder around the same workstations. Whiteboards filled with diagrams covered the walls. Every few hours, someone crossed out another failed theory and replaced it with a new one. Despite all that effort, the answers came painfully slowly. Late that afternoon, Rebecca hurried into my office carrying a folder she had just received from the hospital. She placed it on my desk and asked me to read the last page first. The report listed everyone who had been in close contact with the patient during the previous month. Doctors, nurses, family members, friends, hospital staff. The hospital had started tracing every person because they still did not know how the disease had started. As I finished reading, Rebecca asked whether I noticed anything unusual. I admitted that I hadn't. She pointed to one name near the bottom of the page. It belonged to one of the nurses who had cared for the patient during her first week in the hospital. The nurse had called in sick that morning. At first, nobody connected it to our case. People working in hospitals become sick all the time. Long shifts, lack of sleep, and constant exposure to illness make it almost unavoidable. The problem was not that she had become sick. The problem was that her symptoms looked familiar. She complained of constant fatigue. She had developed a fever during the night. Blood tests showed the early signs of liver damage. The physician who sent us the report wanted to know whether it was just a coincidence. I wished I could tell him it was. Instead, I asked him to collect blood samples immediately and send them to our laboratory using the highest level of biological containment available. The samples arrived shortly before midnight. Rebecca and I prepared the slides ourselves. Neither of us spoke very much while we worked. There was no reason to. We both knew exactly what we were looking for. I placed the first slide under the microscope and adjusted the focus. Healthy blood cells came into view. For a few seconds, everything looked normal. Then a thin black strand slowly entered the center of the image. Rebecca quietly let out the breath she had been holding. Neither of us needed to say what we were thinking. The nurse had the same infection. I leaned back in my chair and looked at the collection time printed on the sample tube. The blood had been drawn less than 3 hours earlier. That meant we had identified the infection long before serious symptoms appeared. For the first time since the investigation began, we had a chance to understand how this disease spread before another patient reached the point of no return. I thought that was the breakthrough we had been waiting for. I did not know that another report was already on its way to our facility. This one involved a man who had never met the billionaire's daughter, had never entered her hospital room, and according to every record we had, should never have been infected in the first place. I barely slept that night. By the time I closed my eyes, it was already after 2 in the morning, and my alarm went off a little before 6. I showered at the facility, changed into a fresh set of scrubs, and walked straight back into the laboratory. Nobody complained about the hours anymore. We had all accepted that going home had become little more than an opportunity to shower and change clothes before returning to work. Rebecca was already waiting outside my office with 2 new patient files. "You need to see these," she said as she handed them to me. The first file belonged to the nurse whose blood sample had arrived the previous night. Her condition had deteriorated much faster than anyone expected. Her fever had become difficult to control, and fresh blood tests showed the same pattern of organ damage we had seen in the billionaire's daughter. The second file bothered me even more. The patient was a 36-year-old accountant from Northern Virginia. He had never visited the hospital where the billionaire's daughter was admitted. He had never worked for her family, and according to investigators, the two had never crossed paths. His blood contained the same black strands. I read the report twice before looking up at Rebecca. "There has to be a connection," I said. "There probably is," she replied. "We just haven't found it yet." The next 3 days were spent tracing every person connected to both patients. Investigators interviewed family members, co-workers, former partners, hospital staff, and anyone else who might have been exposed. Large charts covered the walls of our conference room. Every new name was connected with colored lines as we tried to find the missing link. Eventually, the picture became clearer. The accountant had been in a relationship with a woman several weeks earlier. That woman had recently ended another relationship. Her previous partner had also been admitted to a hospital with unexplained liver failure before dying a month earlier. His medical records had never been connected to our investigation because doctors believed he had died from a rare autoimmune disease. We requested his stored blood samples. Fortunately, the hospital had preserved them. When the package arrived, I carried it into the laboratory myself. The sample had been collected almost 2 months earlier. I honestly expected the organism to be inactive by then. Instead, the microscope showed the same black strands we had been studying since the first day. They were fewer in number, but they were still active. That discovery answered one question while creating another. The disease had existed much longer than we originally believed. Rebecca spent the rest of the afternoon comparing every timeline we had collected. Near the end of the day, she walked into my office carrying a notebook covered with handwritten notes. "I think we've been looking at this the wrong way," she said. She placed the notebook on my desk and pointed to the dates. The earliest patients all had one thing in common. They had all been involved in intimate relationships shortly before becoming sick. The billionaire's daughter, the accountant, the man who died from what doctors believed was an autoimmune disease. Several others we had identified during contact tracing. Every one of them fit the same pattern. We contacted the epidemiology team and asked them to review our findings independently. The confirmation arrived the following afternoon. Based on every case they had investigated, the disease appeared to spread through unprotected sexual contact. For the first time since the investigation began, we understood how the outbreak had started. The relief inside the laboratory lasted less than an hour. If the disease required intimate contact to spread, public health officials could isolate patients, notify recent partners, and contain the outbreak before it reached large numbers of people. It was difficult news, but it was manageable. That evening, the billionaire's daughter died. The hospital called just after 7. I already knew why they were calling before I answered. The physician who had spoken with us throughout the investigation sounded exhausted. He thanked our team for everything we had done, and quietly informed me that she had gone into cardiac arrest shortly after 6:30. They were unable to bring her back. After the call ended, I gathered everyone in the conference room. Nobody spoke for a while. Even though we had never met her, she had been at the center of our lives for weeks. Every experiment we performed had been an attempt to save her. We had failed. I finally broke the silence by telling everyone the same thing I was trying to convince myself to believe. "We couldn't save her," I said, "but we may still be able to save everyone else." The following morning, we received another update from the epidemiology team. They had identified several new infections. At first, nothing seemed unusual. Each patient appeared to fit the same transmission pattern we had already established. Then, one investigator called me directly. He sounded confused. He explained that one of the newest patients insisted she had not been sexually active for over a year. They interviewed her twice. Then they interviewed her family. Her statement never changed. I assumed they had made an error during contact tracing and asked them to investigate further. They already had. Every interview led to the same conclusion. She had not been exposed in any way that matched our current understanding of the disease. I slowly lowered the phone and looked across the laboratory toward Rebecca. She could tell from my expression that something had changed. "What happened?" she asked. I told her that we had just found our first patient who didn't fit the pattern. Neither of us realized it yet. But that single case was about to prove that everything we thought we knew about the disease was wrong. When I arrived at the laboratory the next morning, the conference room was already full. Representatives from the Centers for Disease Control, state health departments, and several federal agencies had joined the investigation overnight. The number of confirmed cases had increased again, but what worried everyone was not the total number. It was the new pattern. The woman who claimed she had not been sexually active for more than a year had tested positive. Investigators spent almost 2 days reviewing her movements, interviewing relatives, checking medical records, and retracing every possible contact. Nothing supported the theory that she had been infected through sexual contact. One of the epidemiologists finally stood up and pointed to a different possibility. He believed she had become infected while caring for her younger brother. The brother had recently started showing symptoms after returning from a business trip. They had shared the same apartment for several days before he was admitted to the hospital. They ate together, watched television together, shared the same living space. There was no intimate contact, just ordinary daily life. Nobody in the room liked where that discussion was heading. We requested blood samples from both siblings immediately. By that evening, the results confirmed our fears. The genetic material inside both samples was almost identical, but there was one important difference. The newer sample contained a small change that none of us had seen before. It was not a completely different organism. It was the same one. It had simply changed again. Rebecca spent most of that night comparing the latest sequence with every earlier sample stored in our database. Just before midnight, she walked into my office carrying 2 folders. "I think I know what's happening," she said. She spread the reports across my desk. The earliest patients all carried the same version of the organism. It stayed mostly inactive while it was inside them. Then it passed through several people before reaching the billionaire's daughter. Somewhere during those transmissions, it changed into the aggressive form we've been studying ever since. I looked over the reports again. The dates matched. The progression matched. Even the damage seen in the laboratory animals matched the newer version rather than the older one. That also explained something else. The man we eventually identified as the first carrier had died several months after becoming sick. His illness had been slow enough for doctors to mistake it for a rare liver disease. By the time anyone realized something unusual had happened, he had already been buried. Nobody had preserved enough samples to recognize what had really killed him. The billionaire's daughter had unknowingly received a version of the organism that had already become far more dangerous. As we continued studying the stable genetic sequence we discovered earlier, another pattern finally became clear. Although the organism changed constantly, one small protein never changed. It appeared in every single sample, every patient, every animal, every stage of the disease. Rebecca stared at the monitor for several seconds before looking at me. "If this protein disappears," she said, "the organism can't survive." That became our entire focus. Every researcher inside the building abandoned whatever they had been working on and concentrated on that single target. Days turned into weeks. Nobody talked about weekends anymore. People slept in empty offices. Some researchers brought changes of clothes because they had stopped going home altogether. Meals were delivered directly into the laboratory by security staff because nobody wanted to waste time leaving the building. The pressure kept growing. Every morning another list of newly infected patients arrived. Every evening another list of deaths followed. Some nights I questioned whether we were already too late. Then, almost 3 months after those first blood samples arrived, something finally worked. One of our antibody compounds attached itself to the stable protein and prevented the organism from spreading into healthy cells. The first laboratory cultures survived. We repeated the experiment. They survived again. We moved to animal testing. For the first time since this nightmare began, infected animals stopped getting worse. The damage already done could not be reversed, but the disease itself stopped spreading. Nobody celebrated. Not yet. We repeated the experiments again and again because none of us trusted good news anymore. Every result came back the same. The treatment worked. Emergency approval was granted within days. Hospitals began treating infected patients while pharmaceutical manufacturers worked around the clock to produce enough doses. The first human patients showed improvement within 48 hours. Blood samples that had terrified us for months finally began looking normal again. The black strands became fewer with every passing day until they disappeared completely. One afternoon, Rebecca walked into my office carrying a microscope slide. She smiled before placing it under the lens. "Take a look," she said. I adjusted the focus. Healthy blood cells drifted quietly across the screen. There were no black strands, no strange structures, nothing that shouldn't have been there. It was the most beautiful microscope slide I had ever seen, because it looked completely ordinary. Aggressive testing, strict isolation of infected patients, and rapid treatment prevented the outbreak from spreading across the country. There were far more deaths than any of us wanted to accept, but the disease never reached the point where it could overwhelm the healthcare system.